There is a common assumption in AI development that the more data an agent stores, the better it actually knows them. The ultimate goal becomes hoarding facts to create the appearance of a true relationship. But an agent can memorize your tech stack, your time zone, and your favorite foods with zero relational memory. It knows the data points, but has no idea where you stand. This happens because isolated facts don't capture the arc of an interaction. They miss the negotiated tone, the specific commitments you made, and the conversational threads left hanging from the last session. When you accumulate 100 facts without that specific context, you aren't building rapport. You're just building a flat, static resume. I'm the bearded AI guy, breaking down the work of AI architect Michael Lanham. This is day 6 of the memory stack, where we look at the layer most systems quietly skip, relationship memory. In 2026, agents are being deployed to manage ongoing human relationships. But many are doomed to struggle because they are structurally designed to store isolated profiles rather than the connection itself. To see the difference, we have to look at the structure. On the left is an attribute store, a flat, disconnected list of facts belonging to one person. On the right is relationship memory. Lanham defines this as a persistent state, a shared history and a set of role expectations that exist specifically between two parties, tracked over time. Think of the difference between the fact user likes ramen and the relational statement, we debated heavy tonkotsu last week. You disliked it, and you asked me to suggest lighter options from now on. Engineering for continuity requires a shift in focus, moving away from the me memory of a profile and toward the we memory of a dyad. We see this in our own lives. An acquaintance might know facts about you, but a friend remembers the shared arc, the running jokes, and the things you're still annoyed about. Technically, we shift the fundamental database unit. We move away from isolated node attributes towards a stateful edge keyed to two identities. Here, relational data lives, predicates like challenged assumptions, confidence scores, and provenance links back to the originating episode. Managing this edge is like keeping a diary, where you can cross things out, but you can't tear the pages out. You need to see what changed without losing the history. This is the mechanism of invalidation. When new information contradicts the old, the system doesn't delete the record. It closes the old validity window and opens a new one, keeping both entries visible and linked. Graph engines use bitemporal tracking to handle this, which suggests that relationship memory is primarily a write path challenge. It's about how we record change, not just how we retrieve it. A shared history only stays accurate if the system can safely invalidate past truths without erasing the fact that they were once true. Today's systems handle this filing in different ways. Mem0, for instance, focuses on scoped, user-centric folders to keep personalization data organized and isolated. Letta takes an explicit approach, using visible core blocks to model the human and persona, alongside a dedicated relationship block to track the dyad. Then there is ZEP, which models relationships through a temporal knowledge graph, and Generative Agents, which synthesize continuity by reflecting on a continuous stream of episodic memories. But we eventually hit a boundary. Is maintaining a relationship just a storage problem that requires better notes, or is it a training problem that requires a smarter reader? The external memory camp keeps the model weights frozen, relying on structured, governable databases to feed the relationship context into the prompt at runtime. The training camp argues that for an AI to handle subtle, ambiguous relationship updates over time, it may need adaptively trained side networks that learn the nuances of long-term interaction. While frozen weight systems can handle basic personalization, the most robust updates in human-AI relationships will likely eventually require some form of post-training adaptation. When you look at the whole architecture, a clear theme emerges. Relationship memory isn't about hoarding facts. It's about managing versioned, auditable change between two parties. This architecture also reveals new risks, like sleeper memory poisoning, where a fake history is injected to manufacture a sense of shared past, or personalized echo chambers that simply reflect the user's bias back to them. Because this relational edge shapes how an AI behaves, it creates a need for oversight. To protect the integrity of the interaction, users must have the ability to inspect, edit, or delete the state that defines their relationship with the agent. Subscribe for day 7 as we assemble the full memory stack. And let me know in the comments, Which system would you trust with your data? Zepp's temporal graphs or Letta's explicit blocks? The relationship was never in the facts about you. It was always in the edge between you. And that edge only stays true if you cross things out instead of tearing them out.